Bismillah. We'll talk quickly about reversible and irreversible damage of the cell, which really depends on the mechanism of the damage. It could be apoptosis or it could be necrosis, and both of them, of course, are going to be irreversible damage. But the idea is, what point does the cell, not able, or is the cell not able to recover? First of all, we start with hypoxia. We have reduced oxygen phosphorylation and thus reduced ATP. With the reduced ATP, we're going to have reduced mechanisms of the cell. So NAK pump, sodium potassium pump channel is not gonna be working, and so the sodium will accumulate inside the cell. Salty cell, swollen cell. The cell will become very swollen because the salt brings in the water. And of course we have chalky cell because it will have the lost function of Ca pump, which pumps calcium out. Calcium will stay in the cell, and of course that's going to be a problem for the enzymes later on. Another thing, it's a sour cell because you have too much lactic acid, because you're just doing glycolysis at this point to make ATP, and you're not doing anything with the lactic acid after that. So you're not neutralizing the lactic acid. Sour, chalky, salty cell. Okay, sour, chalky, salty cell. So what happens to this cell that is swollen right now? So what's gonna happen is that your cellular membrane will become blebbed like this, yeah? So you have these blebs outside of your cell, outside on the membrane, and it's the hallmark of reversible damage. Now, the swollen cell is the hallmark of the reversible damage. It will be the swollen membrane and the swollen rough endoplasmic reticulum. With the swollen rough endoplasmic reticulum, you can imagine that it is a spring, and this spring, if it just opens up like this and gets swollen, it will just throw away all of its ribosomes, and ribosomes will be dissociated from the rough endoplasmic reticulum. That's basically what it is. Okay, so you have better pictures in here than my drawings, and this is basically reversible damage. If this goes into more of damage, that will be the hallmark of irreversible damage, which is the popping of the cell. What is the popping of the cell? I mean membrane damage. Okay, so the damage of the membrane will make the cell basically, have a pore. Yeah, so these pores, basically the damage on the membrane, will make it not able to go back into recovery. Okay, if it recovers, it can recover, of course, because it can retain its cellular membrane and just repair the damage on it. Okay, so irreversible damage, what happens? Membrane, mitochondrial, and lysosomal, all of them will have damage. So with the membrane damage, you will have leakage of calcium in and enzymes out. Your enzymes will affect the other cells, and you'll have something like troponin as your marker in the blood serology, if you want to remember that. Of course, the cell will have the membrane gets dissociated like that. Your mitochondrial damage will be the problem that is going to cause apoptosis because cytochrome C. What happens? So mitochondria has the cytochrome C, and what's holding it in is BCL2. Okay, BCL. How do you write that? BCL2 2, and BCL2 is basically the protein that shuts down the doors of the mitochondrial membrane. But of course, if your door is broken, your contents will, just leak inside the cell. And of course, cytochrome C will have so many steps until you reach the caspases that will basically have the nucleases and the organelle damaging enzymes. At the end of the day, you're going to induce apoptosis. Lysosomes basically get damaged and your enzymes leak inside the cell, outside the cell. It eats everything, just like this. So it's either necrosis or apoptosis. Of course, necrosis will be in this case because you're gonna have hypoxia. It could be apoptosis, it could be necrosis. It doesn't really matter that much, but there are differences which we'll go over next time. All right, thank you.